You know, I think. And of course, this random shooting. No, go away. Oh, go away. No. Just use a move. Where is everything? There it is. Well, that's something. Something there. Oh, by the way, YouTube, how did you do? The YouTube seems to be working. Great. Oh, hello. I need software development, sure. No, wait. Okay, it worked. Wait a minute. Wait. Oh yeah, there's the background noise. I understand about the copyright claim, but he didn't. I didn't read the description properly. Let's see if it happens again. Surely not. Surely. Yeah. What is it? No, it's nothing. Yeah, could be nothing. Okay. Wow, that's terrible. Man. By the way, are you using the... hello. That works. Oh yeah, I forgot I'm not in studio mode. Okay. Anyways, yeah, I went to study the backpropagation. Then, with MapleStory, I studied the derivatives. Later on MapleStory. Studied the cost. Also known as the loss function for some reason. Studied the MapleStory. And now we're here, actually. Oh, that is... I think it's louder. Oh man, yeah, but that's louder than I thought. It didn't be that loud. That's good enough. Okay, so anyways, we got kind of work to do. We got gotta get the backpropagation working. It's a bit involved, but I also got the stuff for it. Got the stuff. So maybe we should start there. Actually, I can actually now draw. Right, the erasure never worked in Paint. Wow, that's terrible. Should I use the backwards button? Okay, good enough. Point is, we can start with the... Okay, where should we even start? There's the main question. Because there's a lot to get through. Wait a minute. That paint is fun. What's the 2 paints? Why do I even have a paint? What do I have 2 paints? What are 2 paints? Lady. Okay. The other paint is unimportant. I'll close it anyways, soon enough. Okay. Anyways, now I gotta focus. What am I doing? Okay, we gotta just start with the derivatives. So, you know, could put in a lot of effort, or I could just copy the notes. So we got some stuff. We got some stuff. Wait a minute, what happened here? Okay. Well, it's a bit big, but I think it's fine. At least it can be ready. So we get this whole thing. I'm gonna explain it. Okay, so this is just the error. By the way, does that show up? Ah, hell yeah. Paint is not. Wait, is paint not? Is it not picking up paint? Oh, hell yeah. Also, what's that guy doing? Okay, you go sleep. Okay, well, okay, paint is not working. Amazing. Are you using the other paint? Okay, we'll open this paint. So here. Oh, okay. I was in the wrong paint file for some reason. Okay, change brushes, change size, really thick. Okay, now we can start. Okay, so this is the error of the very last layer. We need the error. We compute the error in order to better the neural network. We need it for backpropagation, which gives us new values to train the network on. It updates our weights and biases, so we can get a better result from the network eventually. So this al sub, is it superscript? Yes, is used for the oh my god, I forgot to. This organization. Anyways, unimportant. So this is the error. We're getting the last layer, using this superscript al for the last layer of the error. Yes, it's the output. Also known as the output layer. So, where are the... there we go. So, it is equal to... Is it the same? Be sure. Yeah, okay. So, the gradient, this is for the gradient. I don't know why, but it's for the gradient. It's for the gradient of the cost function. Oh, with respect to a, by the way. I could draw a better array. I could draw a small array. Okay, with respect to the cost function. So we get the cost function. Actually, I'll get to the cost function. Well, I'll get to them. I'll get there one day. Surely. Sure. Okay. Then we take the Hadamard product. This was a very crucial step. I thought this was a multiplication for a one, but no, it's supposed to be, I think, the Hadamard product. So we take that, and then we use a that's another sigma. It's supposed to be a sigma, but it's technically supposed to be the activation function for our node, for the node. So the node, if we have a node, maybe I should, okay, if we have a node, it's this one's activation. There's some weight coming into it. There's some, we have a bias that we add to it. We get out the activation. The activation is just the weight times the, well, it's not like a dot product. Maybe I should use dot. It's fine. With the input value, so we have another something here, some input vector usually. So values, unimportant, are very important. And then we add the bias to it. Also, this vector, I should mention that the weight here is usually the weight vector. So if we have multiple weights, it's the weight vector times the input vector. Assuming we have multiple inputs and multiple weights. Yeah. The bias could be different from one for each node, but no. I say no. It's because it doesn't seem to matter for some reason. Can I please have a bigger, does this work? It doesn't. I can't have a bigger erase. I didn't plan to use MS Paint. I wanted to use OneNote, but OneNote was shit in the bed. So, unexpected. Bam. Also, it's not much better. It wasn't exactly designed, apparently, for tablets or graphic tablets. As like I wanted to use the infinite canvas attribute ability of it. Okay, so we got the sigmoid. Oh, by the way, we need to use the we're getting the derivative of it. Don't worry, I don't think I'm getting that. Just have to look it up elsewhere. I'll code it anyway, so it doesn't really matter. Unless I have written it somewhere. Maybe. But it's with what do we have? Oh yeah, the Z of the L of the last layer. So we can overwrite this. The Z is just the. It's not. No. It's the V dub. Okay. Well, wait a minute. I just do that. Dub X plus B L. Yeah. That's good. Remember, dub is a W and X are vectors. Not good. Yeah, they're vectors actually. Never mind. Okay, we got that. Got that. Very good. Very good. Wait, is that it? Yeah, it is kinda it. I mean, we should explain the cost function. I should explain the cost function. Of course, yes. I would have me. So we got the gradient of the cost function with respect to A is just the. I believe it's just considered the Jacobian. The Jacobian. So Jacobian. Oh yeah. Okay, cool. I've already done. Jacobian of the. Okay, cool. Gradient of the cost function with respect to A is the Jacobian of all the derivatives of the cost function. Hell yeah. With respect to the activation. I did the activation today? No. Activation with the specific activation. With the specific activation. Oh yeah. It could be a D or at the D. Doesn't matter. Well, it's the partial derivative specifically. Let's be thorough. And then we continue and we have more derivatives here. The same stuff. Unimportant. Can I please have a bigger eraser? Can I have more canvas space? Okay. No, I can't, but I have a bigger derivative. A bigger derivative, yes indeed. Okay, is that bigger? No. Hell yeah. I don't know what that's doing. So finally, we got the derivative, the gradient for it. That's a gradient for the Jacobian, what do we want to call it? It seems to come with many names. What the hell happened here? Whoops. Brushes. B. Yeah. At bus. No. Yeah, I don't know. That broke would be cool. Alright. We don't need the activation. No, we don't need the activation. The activation is the. Wait, it's the activated. Wait. Let me read my notes. I made so many notes. Right. So this was really hard to find for some reason. Godforsaken reason. Apparently there's multiple ways to derive the goddamn cost function. I don't know why. At least for the mean squared version. This is just the... I'm not going to do the derivation, actually. That we are gonna screw. Well, we could do it. I don't wanna. It's wait, actually, it might just be. Okay, I'm not even sure if this is the correct. This should be correct, actually. Then what? Probably fine. This should probably be fine. It's a the n. So the elements. Wow. Sum of the elements. I suppose 1. We'll be using 0 for the indices, but screw that. But we'll just use the mathematical notation. The height minus the y. So the y is the true output. True, man, that's not good. Wow. Try reading that, anyways. Ooh, that's the expression. We take the sum, and it's as many elements as we have in the as we end up having. It's for whatever amount we have the outputs. Whatever output amount we'll have. Yeah, that's good. Yeah, I think I've explained myself there. Okay, but anyways, there is the derivation. I think the original I say 2m. No, is it 2m? I don't think some use 2m, some don't. I don't know why. It's very weird. It's supposed to be like 1n. And there's some. I can't remember if this is how you're supposed to derive it. I presume it is y and then squared, and then when you derive it, you just take the square of y. Oh, that's the giga shared shoulders we wanted. Making pancakes. Thanks for coming by. Exactly, I did it. I followed your advice, your grand advice. It's amazing. Okay. That doesn't look like a 2 square anymore. And if I take this, wow, that's wrong. 2 square. Bring that from the front to the front, so we get that. It's very simple. Power rule of the derivatives. I think that should work. If it doesn't, well, I'm gonna go find how to fix it. Okay, I think that deals with that part. Yeah, this is the mean square error. Oh, by the way, this is, I should probably note that. Mean square error. Okay, mean square error. The function for at least. Okay, what's next? Are you writing your own neural net library? Pretty much. I'm at least making the basic neural network library. I just want to see if I can and how the mathematics works. After I've done that, then I can use PyTorch and TensorFlow and whatnot without creating my own stuff. But this is, you know, mainly to learn. Nice, yeah. This is kind of nice. It took a really long time to understand what's going on in backpropagation. Feed forwarding is a bit simpler, or a lot simpler. We don't have space anymore. Wow. Can I make more space? Oh, I can. Whoop. What if I just make a lot of space? Streaming. Anyways, so that the oh yeah, the derivative. Well, we're gonna be using Rail. Derivative of our activation function. We're gonna be using Raylu. I think that's wow. That's how they wrote it. So we just get out. Wait, what is it? It's 0 if 0 if I think it's weight plus bias. Weights times the inputs plus the bias is less than or equal to 0, if I remember. Wait. Yes. Else... Wait, was it 1? Wait, now I'm confused. Where's my note on this? Did Raylo really do that? No, I think it did. Else 1. Right. Because otherwise the normal Raylo just gives back the value itself. Right. Ha! Amazing. Oh, yeah, I need to test out the mean absolute error eventually. So, next up. Actually, that's about the same. So now we want the error of each layer. How do we write this? Let's just do this. Let's retry. There's supposed to be an L or something. Layer for each layer. That was the previous one was for the last layer. This is for the current. And it's okay. That's a tough one. The W. Okay, of the layer. Next layer. So I'm gonna explain it in a bit. First. Oh yeah, transpose, right. I'm not gonna draw it by the way. Because I don't remember how. Sure. Whoop. Plus 1 times the error of the previous of the layer. Of the next layer. That all makes sense in and then Hadamard product, I believe. As I've been light. The derivative of the well, it could be a derivative. The prime or a derivative. Yeah. Man. With the wait. I need let's just redraw the Z. Man. Excuse me? Oh. Okay. Z. Okay. Y. It's the layer. Yeah. So values of the layer. Okay. So, getting all the weights. So we have some. Okay. Let's do this. Anyways. Wait. The reason we want to do this in backpropagation is because we get the from here we get the last layer error from here, and we also have these weights. So we want to get these layers errors with by using these values, these weights, and this error. Or well, actually, it's these errors because it's multiple. It's all the errors up here. This is one. There would be one, but if we had another node, there would we would have 2 errors for each. 1 error for each. Hello, I made it. Hey, Red Lizard. Been a while. Welcome. Man, that's gonna turn in the code soon enough. Okay. We got the layers. We got the error. Then we hardwired that. Oh yeah, hardwired is just a element-wise operation, so it's basically a dot product. I got access to a pre-alpha build of We Happy Few. Wow. Ooh, sweet. Nice. Wait, how do you get that? Is it really available? Oh yeah, the harder mark. I'm just gonna do this. It's basically a dot product. Well, I think it's dot product, but it works for matrices. Build 11915. I got it off the internet. Ah, neato. Found any goodies in there? Okay, well, that's happening. So the Hadamard product does magic. Basically, we can have a matrix 1, 2, 3, 4. I think it's only works for equal sizes. Not a Trojan virus, the god. Yeah, yeah, that is a good thing. It's when the player started to talk. Oh, I see. Interesting. So wait, they didn't talk before? Interesting. You were happier people in the pre-alpha? And you could talk to wastrels. It's also bloody hard. Wait, okay, that's interesting because the actual game isn't that hard. But that's interesting. Okay, but there's, I think it's only, the Hadamard only works for two matrices of the same size, or vectors even. I believe. So y1, y2, and y3, y4. So that is just new matrix of x1, y1, x2, y2, x3, y3, x4, y4. And so we have our Hadamard product. You could build 112, build 11215, you couldn't talk. Oh, interesting. And wastrels were much more creepy. Ooh, that actually sounds kind of interesting. And bobbies were like gods, you couldn't defeat them. Oh, that would have actually made the game way more intense if they were godlike. Way more intense. So I dealt with the Hadamard product. Do you leave anything out? There's a derivation for it. Oh yeah, transpose of the weights. Right, the reason why we do transposes... Okay, we don't know what transpose is. If someone doesn't know what transpose is, it's just basically we have a weight vector, for example. So it's like this. 1, 2, maybe 3, okay, extended. It's also super loud. Interesting. Look at gameplay on my channel. Oh, interesting. I'm gonna check it out after stream, at least. Yeah, we're gonna have the weights. So this weight transpose would be just actually wait, it's would be weight 1, weight 2, and weight 3. Actually, it shouldn't probably be using the commas. They're not usually used. Anyways, now you got this. I can start to see why they never used the brackets here. Okay. Instead, this was used. These are used. Good. Cool. So get rid of them. Maybe clean up a bit. Okay, weight 3. See, now we got the nice transpose. Basically, columns become rows, and rows and columns become rows. Very simple. My God. Yes. Indeed. Okay. Ooh. Then we got the. We need the derivative of what the? Oh yeah, cos function with respect to the bias. Oh yeah, we have The players are making random sounds. Oh, hey, interesting. Interesting. Okay, we have the bias function. With respect to the bias, it's actually the official one is layer with the specific bias. So each node's bias. The layer and then each node's bias. So again, we might have a layer. This is the layer. It's the layer. Layer. And then we have bias. But technically we are using just one bias, but they all get... How did you know that I was thinking pancakes? Wait, so usually this is the... Usually this version, wait, what? It's error. The error of the... Where is it? Yes, it's the layer... The derivative with respect to bias is usually the... Just the error, layer error. Rabbi died. RIP. RIP, buddy. Too bad. Okay, there's it's usually this, but it can I think it was generalized to, yeah, it is. It can be generalized for all the layer nodes in the layer with bias. The bias and layer, which is error of the entire layer. All the errors in the layer. I forgot what the purpose of this is. And I just getting the bias stuff. Wait, what did I need? Alright. It updates the biases. Right. This is for updating biases. Right. In the future. In the future. Once we reach the end. That was the simplest one. Linear algebra, kinda. It's linear algebra. I think it's actually linear algebra and calculus. We got derivatives and matrices and vectors and stuff. So a lot of math. But this is just the preamble or something before we code it. I don't want to go through this because I spent so much time learning all this math, so I must tell someone. So we got the derivative with respect to... Wow. Is this the weights? No, it's a weight. Oh my god, do you have background in math? You don't seem scared in front of equations. I don't have a background in math previously. I just learned most of my math and I've been learning it in university. I just know, the thing is, I just know that I can learn the math, so, and I kind of like math. Well, I do kind of really like math. So it's very fun for me. Not for everyone, but for me it is fun. And since I'm trying to become a researcher in artificial intelligence, I need to learn this math anyways. As a math, algebra, geometry. That's good to enjoy math. I just like math. Math is good. And it's work. Oh yeah, I need the height. Where's the... Ooh, I forgot. I must have forgot. With weights we have... The notation here is... Wait, there's weight. If I remember correctly, it's the... So, wow. Actually... Rare breed of people we are. Have a master's in math. Despair. I got an idea in algebra and 103 in geometry. I don't know what those are out of, but that sounds really good. It's a nice job. A rare breed of people. A master's in math, yeah, I don't think I would want to do that. Because math, I think the higher level maths, if you study for become a mathematician, you start to have to do proofs. And I suck at proofs. 98 is A+. 103 A+. Oh, very nice, very nice. Very nice. That's very. Okay. We got the weight. Oh yeah, the weight notation. If I remember correctly, it's full. We got the weight, we got the layer here that we're playing with. So this weight corresponds to this layer. The notation is that. Wait, actually. Nice. I is the. I keep forgetting. It's the current node we are on, which is the 0th node. This is 0 or 1, could be 1. Let me just do this instead. Because it makes it more obvious. And then we are coming from the second node. So this is 0, this is 1. We're coming from the second node. It's going to be for J. J1. That for J. We come from there. Okay. God damn it. They keep changing the names. Anyways. Oh, it's JK? What? It's not IK. It's JK. Well, ain't that something? Anyways, we got that out of the way. Do I need space? Maybe not. Then, yes, this is simpler. It's the wait. With respect to weights, yeah, we get the weights, the new weights basically that we'll be using, or not the new weights, but the weights we'll be using to calculate the gradient descent with. And I almost forgot about gradient descent. The previous layer. No. It's a previous layer's activation, right? That makes sense. Okay, times the error of the current layer. Current layer element. Am I sure we can't simplify this? Yes, you can. Ooh, hey, that's very interesting. So we can just do this. We do magic. Not magic really, but do this. How do I? That's not how. No, I see. There we go. Okay. What happened? Whip. It stole my C. Okay, it's the error of all the errors in the layer times the activations in the previous layer. Transposed. You know, we're doing the matrix operations again. Oh, sweet, that's how we get all the new stuff. Okay, so that's all the functions we need. Well, we need the gradient descent one, which I think I have somewhere. Oh yeah, I do. Oh yeah. We calculate that. Set to errors, make errors. The result. Right, we concatenate. Where is it? Oh yeah, now I remember. The gradient of the dub weights with respect to weights and biases. I think they can be written the other way around as well. Or maybe I'm just writing them the wrong way. Anyways, the cost function with respect to the weights and biases, just the it's basically, I guess it's basically the derivative of C of the cost function with respect to the weights plus the, well, plus, is it really plus? I think it might be, no, it's not really plus, it's concatenation. I don't know what the symbol for that is. So we're just gonna use plus. Nate. Haley. That works. The buzzes. Wow. Oh yeah, actually, it's not just one layer. It's all of them. Wait, not errors. Well. All layers in this case. The other ones are individual. Well, we don't. Is it really concatenate? We make a single vector out of them. Is it reshape? Might be reshape. Basically, if we have a. Actually, I think we get out a. Something weight. Then we get the plus the. Plus 1, plus 2 maybe, and then we get. Is it? No, that didn't. We're supposed to get something maybe like weight B1, weight 2, B2. And we're supposed to make it into a single vector with weight 1. Wow. Weight 2 and bias 1 and bias 2. Very cool. Okay, good. Almost out of space. I'll be almost there. This can't possibly take long. It's practically done. Okay, gradient descent. It's for some reason a tail. Whoever thought that was a good idea? I don't know. Could have been a big G, but it wasn't. So it's the tail. How do you just... Tail is gonna be the same size. Have the same shape size as the our new vector. But I don't remember if it's initialized with 1s or 0s. I think it's zeros. We'll see. Actually, we won't because it'll just break. It might just break. Same size as B. Yeah. Then we take some alpha. Alpha is just the learning rate. So we're making small steps. We have the graph whatever, maybe it's 3D, and we're making small steps instead of jumps. Oh yeah, there's gonna be batches also. Batches are just, we split the data into smaller quantities. That will make sense one day when we get to the code. Okay, get rid of those. With the learning rate, and then, oh yeah, it's just it's a new vector body. Okay, paint, it's enough. Stop, you don't need to delete anymore. C, yeah, it is that, and now we got the oh yeah, the learning rate is usually something like 0.001. There are ways to I think automatically find it. Or you can do it manually. Usually you can manually find it as well. Okay. Anyways, we got that. And then we update the weight, the original weights of biases. That's my understanding. At least. So I don't know if we just plus them. Or just... I think it's just plus the original. The original weight vector plus... Well, for each... It's for each vector. Each layer and their weights. It would be something like would it be? It would be some. It would be some most definitely. It would be the weight. It would be the OG. So this, if this contains all the weights and buys all the weights, so can I just make interesting. 4 layers, maybe. No. Yes. Maybe you make it fine. Maybe that'll work. Then I need Edgeman. Or maybe Dutchman. Should figure out. Wait a minute. There's the sum. Maybe it's some. Old. New. That's with layer weights. Maybe I should have not used either. Doesn't matter. Is it in this way? Curious. We get the weights and the weights. Wait, if we have it all the weights separately, then we don't need to bother with the single vector, right? Or not? That's fine. Okay, that's about the math. I don't think there's any more math for now. So we're gonna move on to the actual coding. I wonder if this works. Haha, you thought it would work. Of course it doesn't. Alright. Now we can get to the good part, the math. No, the coding part. Have we got the maths? What is OBS over there? What is OBS doing? What did the OBS doing? Oh yeah, we can just ask ChatGPT eventually. Right. Okay. Water. Okay. Alright, tablet, graphic tablet, you go. You go sleep. Oh, okay. Okay. Now we have the actual code to work with. Interesting. What the? Anyways. Anyways. Now we can actually code stuff. Well, we should really figure out where we're starting from. Oh yeah, this guy. Okay, what was the first one again? The guy. So, I'll make the I might see. Oh, Mike D. Define. Ooh. Oh yeah, paint. You can go sleep. Interesting. I might need to have that on. Just close it. What are you doing? What? Don't. This one? Sure. Oh, what are you doing? Close enough. Bye. Okay, that thing's out cold. So now we can use the find the error. Last layer error. Okay, what error? I see. Anyways, last layer error. Okay. We're taking the math. So we're supposed to take in the what is it called? It's the cost function with respect to a. The gradient. Cost on gradient. PRT A. That might be the stupid little long name, but that's fine. This is clear. That and ooh, that's No. We'll be doing that. We don't want that. So what we take in is the Did I ever expand this? You know, considering I just did the maths, I'm surprised at how little I remember already. Okay, let me find what I wrote. Okay, let's open a new window. I want to read what I wrote. Read what I made. That's not it. How many options do I have? Okay. Is this anymore? Nope. Where is it? How is it not there? Where did you put it? It disappeared off the ether. Paint, you bastard. You can't be serious. It's gone. My mathematics. It can't be. It can be. I see. It's not here. No, that's how many times I look. It's not in there. How could this be? How could this be? Yeah, paint. Where did you hide my stuff? None of these are correct. Where did you put it? Where did you put it? It has to be somewhere. It's in D, all the way in D. It couldn't be. I need JPEGs. On download? Okay, it went. I see where you went. There you are. Okay, I can't. Let me zoom. I can't read like this. Alright, good. But I'm not gonna. It is. No. Shush. You smart one. Can you close that? Okay, let's open it. It opens automatically with the paint. Let me open with the. What happened to Windows Media Player? Or the. Well, Media Player is close enough, I suppose. Okay. Video manager. It actually opened it. Wait a minute. Maybe not. Because I don't think I can zoom with that. Where did the Windows, the default system viewer go? You'd be shitting me. Open with. Oh wait, I'm starting to realize that I probably don't even have it. Right. Yeah, everything opens in Paint. Right. So it wasn't just one thing. Why that happens, I can't remember. I think I nuked something a very long time ago. So, whoopsie. Maybe actually I could keep this running. What happened here? Okay. Well, I guess I can read like this. What are we doing? Right. We need the derivative with respect to something or the other. Something with the y. Right. So with activation, god damn it. Of course. Okay, we'll need okay. I'm starting to realize we can't do much here. I have to first go for the damn it. Mean square error. Okay, that one takes in the output. Is it output layer? I guess it's the output layer actually. Output layer with the expected layer, I suppose. Oh yeah, divine. Whoops. I don't think I should name it output layer. Outputs. Maybe let's make it outputs. Hell yeah. Okay. For some reason it's already defined again. It'll fix itself eventually. Okay, no, it doesn't if. When we do the mean square error, it's just the we could use numpy, but I don't want to. I want to make the whole function myself. What was the original? Yeah, for some reason it's 1 over n. Sometimes it's 1 over 2n. I don't know why. So we'll try with the 1 over n. So the sum, so it's 4, so it would be 4, a for loop. The fuck happened E? Where did we go? Ah, I see the problem is. Before, is it the output? I don't think it matters. Outputs? No. For output in outputs. I'll just rename it later. Hopefully it doesn't break anything. Now so while you're going through them, we're gonna sum. I'm gonna do that. Alright, it's a that's gonna be tough. They're gonna be a bit curious. It is a multi-output layer. Oh wait, this is from multiple outputs. Right. Okay, we can do this. If wait, it is len of output layer goes 1. 1111. Excellent. Makes sense. Return. It is, well, it's a bit weird, but output layer minus expected. Expected layer, it's a bit weird notationally, but don't worry about it. And squared. Oh yeah. Divided by, no, it's just 1 because it's over 1. 1 over 1 is 1. Gotcha. Just whatever that comes out with. Else. I mean, yeah, whatever. Why not? Don't technically need it because of the return, but it's maybe easier to understand. Oh yeah, by the way, if only one output in output layer, hell yeah. Okay, for multiple outputs though, it's the sum. Ooh, Wait, let me think. Something. Let's think about this. Is it just through all the activations? Is it just all the activations or not? Let me check some. Let me check. So we have a 1 0 1 1 0. Let's make it 0 1 0 1 1 and 1. Then we minus that from the, let's say 0 0 0 and 1 1 1 and 0 0 1. Then we get out 1 0 1 with, I mean, it's negative 1 0 negative 1. Interesting. 0 1 1 0, and then we get out a 2 negative 2 and 2. From that we get out 2 0 2. Oh wait, is it? What? No, this is squid. Oh yeah, the squid's kind of useless, isn't it? Oh wait, 3 2/3, I guess. 3 is like 3 6 9. It's over 9. 2 9s, right? Two nines. Let me think between. Wait, return. Okay, return 0, I guess. Doesn't matter. For now, I need to test something out. X T for testing. Numpy array. Let's say one. Actually, let's just use what I have. 0 0. Wait, it's not 0 0. It's 1 0. 1 1 0. Man, stop. 0 1. Alright, I forget. I keep forgetting. Man. Well, I can't wait to get a new computer that doesn't run like this. Anyways. 0 1 0. Come on. No! Good. Oh yeah, the thing's almost broken constantly. And it's more broken now. Oh yeah. 0 1 0 1 1 1 1. I'm gonna make a copy of this just because it's easier, I think. Nah, kind of. Yeah, so it's 0 0 1. Ooh, 0? This one. Okay, cool. I didn't turn on insert. Choose this override over. This is supposed to be 2, by the way. Yeah, okay. Getting closer. 0 0 0. Many zeros. Wait, 0 0 0. Okay, cool. Now we're gonna do. What happens? Wait, print t minus t2. It's supposed to give back what I think it's supposed to do. What did you do? Okay, 1 0 1 0 negative 1 negative 1. Yeah, exactly. Okay, cool. And we need. I think we just need the numpy sum. Why that sum? Actually, yes. Numpy sum. The sum function. The numpy sum. Okay. What do we get out? We should get out. I think it's just 2. There's 2. Ha! I'm so very smart apparently. It's not the mean, but the no, then it's just divided by the thing. Okay, so my math hasn't left me yet. So that's good. What are you doing? Okay, the math hasn't left us yet. Keep it around actually. Ooh, this gets complicated, doesn't it? No, it doesn't have to get complicated. It's the thing. It's the fun of it. Well, it kinda does actually. No mind. I have to make it. Output row. Output in output row. It's gonna take forever. I think there's technically, obviously, there's better ways to do this. I believe there's one. Wait, no, is it that? I actually don't know. Nah, someone's probably figured out a better algorithm. Thankfully, no one has to ever use this. After this is done, we've got to eat through each row. Okay. Then we need to. Right. Output row and then. I mean, I could just do this actually. Output row and expected row. Up in zip. Actually, since they're the same size, it doesn't matter. This all work. There's different zips, but this zip works. Expectably. Sweet. Yeah, what? You what? Up row and expected. No, not layer, but it is close enough. I'll always zip these because I am. Okay, no mind. Zip. Not quite, but we're getting closer. For output E and output and then the expected. Yeah, we're keeping it like that. Okay, now we just have to do output plus expected, and we need to store that value somewhere. Oh, yeah, because we are lazier, we don't need to make a whole ass. Normally you'd make a new whole ass matrix out of this, but it's just redundant. So we can just use the sum. Sum equals 0. I'm just gonna use for notational purposes make 0.0. Because I think it can be a... Oh yeah, sum plus equals... Yeah. Notational purposes because I believe these values can be... Wait, can they even be? But no, I don't think they can be negative. Or I mean... I don't think they can be... floats. But I just realized that they can be floats if we are not using the... What is it? Railer. Yeah, if we don't use Railer, then they can be they can be floats or ints. So they have possibilities. I think that's it for sum. Means then at the end of this, okay, cool. Oops. We just take the sum, or we could just say in. I'm just gonna call it MSC. MSC equals. Oh yeah, I'm supposed to square them. Right. I don't wanna do that. Because why would... Wait a minute. I'm making a plus sign. What am I thinking? It's a minus. Squared. Oh yeah, so we don't get negative values. Oh, wait a minute. That's why we... Aha, right. So my calculations were wrong here. You're supposed to use the square so we don't get those. Ah, right. So we get 0 and 1. I kind of forgot that there's no... At least in Railer, there's no negatives. I thought something was off. Ah, smart. Sum divided by... What is it? I think it says len. Len of... Wait. I don't think it's len. Wait, no, it might be... No, it's len. It's len. Wait. Could it be? How does this make sense? That's how I realize. Something's not making sense. Yeah, this is not making sense at all, if I'm not wrong. But why would you have a multi, an M by M matrix? Why wouldn't you have just a single vector? That's not making sense at all. If you have multiple outputs, it's still just a single vector. Wait. ChatGPT, tell me. Can we out of a and neural network ever matrix, or is it always a vector? It's always a vector. That's a curiosity I have now. I'm gonna be a vector or matrix in the architecture and the specific task. How do you make it into non-vector? It could be a vector or non-vector. Yeah. It could be a matrix, I mean. Generation. Okay, I think there's way more advanced network. But for our purposes, it's always a vector. For this simple network, it is indeed a single. Oh, no, stop, Python, stop. Before I send you. Okay. This makes sense, yeah. This is for this one example, is that for this network, it's going to be a vector. Some divided by the length of, we can use either one. Wow. I'm just going to use the output layer. Stop. That layer. Okay, and then we can return it. Return MSC. Also, you shouldn't be MSC. Maybe it should be MSC. You'll be MSC. MSE. You're a constant anyways. Well, kind of. Not really. Should be M_SE. I think sure, but why not? Can be worse. The name could be worse. Okay, so we get I mean good. No, this works. This makes sense. I think. It's good when I'm not sure if it makes sense. Okay, we can return that mean squared error. Ooh, I don't want to feed in my thingy. I just want to print. It's not supposed to be done this way. This is not supposed to be done this in the way that I'm doing it, but wait, how do we do it? Oh, neuron options later. Okay, I just wanna get a moment to print neuron scopes dot where is it? Dot mean square error. Is it mean square error or square? One or the other. I'll fix it later if I need to. Expected layer any. What the? Oh crap. So you did do what I didn't think you did. Who used the output layer as their name? Who used the output layer? Who is using output layer? Who else is using output? How dare you? Why? Oh, I get it. I'm understanding. I understand. It's missing the self, right? Right. Okay. We can just test it out with X and W. I just want to see if it works at all in the way I want it to. Good point that I don't have any idea it worked. Ah, shit. Do I need to do that? Do I need to deal with that? Oh. I think I had other code for this that already did this. I mean, I used numpy code. I tested it with numpy as well. Square and mean. Okay, can I simultaneously print numpy.square? Okay. I do like mbpp, $pp. But that's not a real thing. We haven't done that. X dub and dub me. I just wanted to see what this does. I want to see if they're the exact same. If they're not, we might have a problem. We might have a problem. Wait, where? Alright. Wait, what? What do you mean? What do you mean this guy's up? Damn it. Damn it. Damn it. God damn it. Plus new line. If I'm not wrong, which I usually... what the hell did you do? That's not what you're supposed to do. Python, stop. Or Visual Studio. Right, Python is fine. Visual Studio is doing something. Let me out. Oh, save as. No thanks. Okay, well, never mind. We saved it. Why did you save that? No, delete. We're not sending that to GitHub. New line. Okay, great. You cannot do that. You can't add it. Yeah, fine. New line like that. New line like this. You can fail. Possibly. What the? Dude, how am I supposed to know what's going on? I don't know what happened. So I'm gonna use this. Do this. Hello. And because I know I can predict the future, I can tell this is gonna be a problem if I don't do hello 2. Okay, hello 1 and hello 2. Okay, so these were not even the thing. Why did I think it was a vector? Why did I think it would come back as a vector or something? Because obviously gonna come back as a single value. Anyways, point is, it works. Okay, mean square error is finally done. So what is next? Can't scroll, can't do anything. Great. Wait a minute. Okay, never mind. I'm gonna look at it. Look. Where am I? Wow. Okay, where were we? We needed the activations. We get the mean square error. Okay. Cool. That's exactly what we should have. But away. I'm gonna do something that's actually git setters actually. Git add that git ignore. You should really add that git commit and mean squared function analyze function error. Added. Maybe I'll is added. Musical error function. Hell yeah. Git push. Nice way of you push anything else. And did it work? Let's see, let's see. Yeah, this is interesting. Right, we got the we're almost at the output layer. Now we just need the derivative of it. Of the cost function. Yeah. Wait a minute. You're gonna be shitting me. Then what was all of that for? I'm just realizing. We're supposed to use a derivatives version. And what was the purpose of even using the creating the mean square? Why is it? It's on my top resource repository. I can't believe this. What is going on here? Okay. I'm gonna have to do something else then. What is the point of mean square? We just use. Wait a minute. ChatGPT, tell me what the point is. What is the point of using a mean squared error function at the output layer if for backpropagation we'd use the derivative oh god derivative derivative it has an A over there. Derivative of it instead. Okay, what is the point of it? Why did I make it? I need justification for this. Was it just handy notation or something? What was the purpose? Why did I do this? No. Okay, I think I have an idea why it's necessary. Yep. Well, yeah, that's my one gripe with this, or question about it. Is it the sum? No, that's I. Yeah. Okay, so everything makes sense. Okay, yeah, I just realized what the purpose of it is. It's used for the when you want to print out the current laws, basically. Right. So practically no value. Well, some value. It's visual value, understanding value. But because we are using the music. Maybe I should make an back road propagation. Okay, it's basically the same. No, well, not basically the same. It's actually slightly different. It's 2 times the output layer minus the expected. Expected. As we established. Well, we didn't establish the single case. We established the multi-output case. So, whoops. Actually, let's just do that. Times. I think it's times 2 times for each. No, it's not. Right, you take the sum of them again, but then here you have 2 times the sum, and then output layer, and that's about it. And let's see, BP. Maybe let's make BP. BP. Okay. Backpropagation version. Okay. It's looking the same. Then we need the Hardamore product. I got the Hardamore function eventually. This should not be like this. I could make a math class. Have we can. Did I? Is this or not? Nah, it's fine. No time to think. Must code. First, with respect to other stuff, and I've broken everything again. Oh, wow, me. So smart of me. Okay. The plan. The plan is going to work. This plan. Whatever is it, bro? What is YouTube doing? Did YouTube stop at some point? Also, what noises is YouTube? It's playing in the background. Okay, never mind. It's playing completely fine. I don't know why it's hasn't. Let's see. I'll copyright claim speedrun. Why is it not playing any? Or why is it playing so quiet? I'm not listening in, so I can't tell. Okay, there you go. Anyways. Oh yeah, define ReLU dairy. Wow. ReLU beat back. I guess I'll just need the backpropagation. Nah, why not? Backpropagation. Jesus Christ, the word is confusing. Self and does it? No, it takes in a value. It takes in something. Taking Z, which is the. It's not quite the activations, but what did we name here? What did we say? The inputs. Yeah, let's just name it inputs. And that's simple enough. Inputs. Wait a minute. Rail? Where's my previous rail? No, activation. Okay. Activation. Wait, this would be. I think it's for the whole AS layer. Is it all the activation section? Let me check. No, that's supposed to be the last layer's activations. The activations of the last layer. activations. Whatever. It takes the, wait a minute. Plus B, yeah, of that layer. Did I not write that correctly? Did I actually fool myself? Be a fool? Was I fooled? Yeah, it's supposed to be, I think, isn't the previous layer's bias? Well, where's the pick? Where's the pick? Why is it, wait, why did I put that there? Right, that makes sense. No, that makes sense. Okay. Anyways, it's the so I'm expecting a vector, I think. So actually return it's either 0 or return. Okay, I get it. My name is second. If activation is greater or equal to greater than 0, then return. I can't use a max function this time around. Very unfortunate. Oh wait, can't I? Wait a minute. Is that max? The arg key. Yes, the key. 0, 1. Key equals activation. Oh wait, it's not like this, I know that much. Oh, max 0. How do I use it? Function? I think it might need a lambda. If the to choose 0, if the activation is 0 or less, and otherwise 1. I guess I might need a lambda. Can I just do lambda? Lambda bear. What? Why? Lambda. Is it lambda? Also forgot the whole ass expression for lambda. X function lambda. Yep, it's lambda. Okay. Oh wait, what the? Okay, we could use it, but it's a bit confusing to read. So It's just cleaner to do this. Or more readable to do this. Turn 1. Well, why not just do this? Let's equal to 0. Else else return 1. Okay, that deals with that one. Now you need the hard product. Hard mod for the hawk. It takes in the one. Wash it again. I mean, this could technically take in anything. Layer and then layer 2. Maybe you should name based on our use case, because yes, it works for others, but nah. But the name could be improved upon. Yeah, great. There we go. It could be okay. It needs self, and then it needs. Boy, what the hell? How? Hello, SAP. Welcome. We're doing neural networks, backpropagation specifically. It's going well. I think the math section has been dealt with. Let's just program it. I need it layer. I forgot what I was doing. Yeah, screw it. For now you can be layer 1 and layer 2. Well, actually it could be... I'm gonna name you... Ooh, maybe not matrix. Matrix 1 and 2. It doesn't have to be a matrix, but now it is. Wait, no. Where's it gonna... Screw this. Select 1. No. Okay, fine, I'll name it differently. Is the cost... What was the cost function? It was called the gradient, right? Yep. Cost 1 gradient. Man. Quite simply really nerd. The nerd emoji. Yeah, it's very nerdy. Indeed. It's fun. Okay. Then we're taking the derivative. One. Wait, no, that's just the result. Oh. Station? BB. I'm gonna name it BB. Backpropagation. Maybe that'll make sense eventually. And simple. Wait a minute. What if it has one value? Didn't consider it. If cost 1 COs. Interesting. Whatever that thing at bottom left has got to be made up. No, it ain't. Ain't no way anyone but in is gonna understand it. What? It is understandable. It takes time though, I will say. It takes time. Take some time. Course gradient. Ooh, wait. Is it len? Did I ever deal with that? Is it len? If it's gradient len. Actually, there should be activations. It's less than... No, it's 1. If it's 1. If it's 1, then we just do... I mean, technically it's just cost. Wait a minute, wait a minute. Where are you from? I'm from Finland. It's a place, probably. This, again, with these naming schemes, these are gonna bite me in the ass. Okay, we need to return the actual, but I have to figure something else out. Yes, and it. How could you tell? It's impossible. Oh no. Cost one gradient activations back. Then if it's just the... I guess we can just make it 0 as element, now that I think about it. This makes absolute sense. 0, 0, 0, 0. Yes, 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 yes. Okay, 0, 0. But then this one... Wait, can it even be of length 1? Then 1. We'll find out. Okay, okay, that deals with that. Ha ha. No, 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 maybe. Who knows if I'm gonna be next time. Well, probably not. I just wanna play with my neural networks. Okay, so otherwise we had to wait. It's 4. For these simple one. Yeah, we'll give it simple. Got one gradient. Wait, isn't it both of them at the same time? Damn it. Wait, actually. Wait for... Gradient, no. For cost and the activation in the zip. Okay. Oh, it's both. I look at both it and my notes. I got both. But they're only mathematical notes. So I gotta translate those. Cause activation 1 plus 1. Activations. Okay, cause and activation. So if you're going through one by one, okay, I'm gonna need a new output. How to mod? Yeah. You'll be empty, yes. And then while that's happening, we just... I mean, this is gonna be rather simple. Append cost plus... Wait, is it? No, it's cost times. Right, I forgot. Cost times activation. Wait, also this is the times, not that. And then we should return. Return how the mod. It's practically the same one. It doesn't deal with multi-dimensional arrays. But this one won't. Doesn't need to, I mean. Alright, that's dealt with. So wait, I can get my entire... Wait, no I can't. Wait, I can. I can't. I can? Maybe. No. Huh. What about the Corel? Advanced. Technically I started maybe 7 years ago, 7 years ago? No, 6 years ago, but I haven't coded, didn't code much during that time, so maybe more like 1 year, 2 years, if it taking account how much I actually coded. I do know theory more than actual practical coding, to an extent. Okay, we got that, but we want to get the gradient cost. Oh wait, cost gradient. Why did I make it one gradient? Cost gradient. You're not getting the function. Or you might be. No, you won't. No, you're not getting the function at all. You're getting that. Okay, cool. Great. Should I make the gradient function? Do I need the function? Selvä, itse on tässä joku 2. Ja puolueet opiskelu. Nice. Nice. Might be better than me. Most likely are. Okay. Do I need do I need a gradient function? It's practically a Jacobian. It's a Jacobian. Oh, gradient. Wait. I mean, it gets the mean squared derivative. Okay. Let's just make it cost 1 gradient naming could use some work, but that'll work. But what is it taking? Cost 1. So taking the cost function and then the... Wait, it doesn't really even need to. All it needs is the layer, activation layer. Oh yeah, it needs self. Whoops. Activation. Wait, it's not, it's the output layer. That's what you need. And then we need to use a cell. No, I don't want to do that. I actually want to... I don't care about that. Or do I? I mean, it's practically. Okay, what does it do is the question. Gives me a Jacobian, which I can simplify. Wait, can I? No. Yes. No. Yes. It's practical. No, I can simplify. What is that? Let me see. So we need to call the self dot backpropagation version. We need to give it the... What are you taking? Ah, shit. We need the expected layer. Maybe I'll just name this. Rename this. Error. Is it the last layer error? Yep. Yep, it is. Not good. Onko sä ikinä tehnyt mitään webdev-juttuja? Yeah, I have. It's technically on my YouTube channel. There's a streams on it. I did Start with JavaScript, DNO, Docker, Linux Mint, web framework, and Playwright. So I've done something. Output layer error actually. Error, okay. Self output layer, expected layer, okay. Wait a minute, doesn't that already do what I wanted to do? Huh. Wait, I might be wrong on this. Activation, okay. Oh yeah, I think I rewrote that wrong. That's fine. Let's get a sum. But if I already have the total, do I need? If I have the total, Shut GBD. Let's do Gex web device. Not a whole lot. Like it's fine. I prefer these neural networks. Prefer, you know, machine learning. And it does have its use cases. But amazing. Huh. I think I just realized the problem here. Ah, shit. Codex 2x, not yet. I'm currently in school for that. Technical. I'm getting a bachelor's, but then I'm gonna get a master's. At least a master's. I'm looking to become a research scientist in machine learning. So it'll take some years. Just realizing. But this is probably not so supposed to do. Wait a minute. Squared error derivative. I'm pretty sure I'm starting to realize a problem here. I am. Whoopsie. But that's not the derivative. Okay, is that the derivative version? No, couldn't be. Actually, could be. Derived version, but wait a minute. Okay, this is confusing. If I already have the total, how does that help me? But then if I take the harder one, then we'd just be doing one operation. And I don't know if that's a good thing. Let me look at my notes. Hello, notes. Have I got yes? I got that, I got this, the arrow. Huh. Right, it's not the... Right, that's why it doesn't matter. I don't have multiple outputs yet. What if I did? No, I have multiple outputs. Need to have values for that. Okay, cool. That's not helpful. Okay, okay. Activations, yes, okay. Okay, modifications. Either one machine got access, the item and arm copy. Ooh, interesting. I'm already in arm call. Yeah. Somehow got in with with papers from media production. Didn't even need to technically take the entrance exam. Don't know how that works, but you know, it does work. Okay, but now Abigail doing something. Not yet. Whatever can't be calculated yet. I didn't. I'm gonna have to devolve my code. Yeah, that's a problem. Oops. Interesting. That's all the activations. That's not very useful, is it? Wait, or is it? Is it? Huh. Jyvitä toimimaan, että pääsisin kanssa todiksella sisään. Yeah. That would be nice. That is much more convenient. So good luck with that. But maybe prepare also for the entrance exam. I took it for the fun of it, and still, and was below the points. By a few points, but still a few points below the minimum accepted. Okay. This is creating a bit of a problem. Should I be getting error for each node in the layer, or the total error in the layer for backpropagation? Maybe. Only have the mathematical damages near get percovers. Rip. Don't worry, you'll have mathematics. You'll have plenty of mathematics in university. Wait, technically, University of Applied Sciences. Mutta aamuko se matematiikkaa? This one, not that one. Wait a minute. This is my performance. Yep, it's each individual node. Hell yeah, I've made it the most. I don't know what the use of this anymore is. Niin se on se, mikä Rosalitas pelottaa. Yeah. How to help people with the web dev? Yeah, I mean, you can get by without the math. Without the math. The math is only for web dev, at least web dev, it's mostly just an accessory. It's helpful, but not necessary. But for the most part, if you have a strong enough basis in algebra, trigonometry and so on, the basics, then all the math is very simple. Or simpler, rather. Performance is the computer of each individual node. Ah, shit. What is the point of this error then, huh? I mean, I guess it's fun to look at, but it's not useful. Okay, so we have to do this. We have to get the output layer. Wait a minute. I don't want the... Wait a minute. No errors. It's got error, lot of loss. Output of that node, Is it just... Wait, output of that node. So each and each error is with MSC is y minus a minus y, right? Right? It should be a minus y, right? I think. We have a plan. I have a plan. For output. Oh my god, I need to do it again. Ei mä teki silleen niinku oo vaikeeta, vaatii vaan paljon oppimista. Mut jos ei hirveämmin harjoitella niinku minä, niin ei... Niin se on aika vaikeeta. Yep, that is true. It does need a lot of practice, especially since mathematics does not, you know, you can't just skip around it, essentially. You have to do it in steps, progressively, because everything builds on top of each other. Okay, okay, I'll plan. Ooh. Good plan. Output, why do I expected one? This is so many of these. I'm just gonna copy paste. Okay, zip. I need a zip. Zip, zoom. Oh yeah. Okay, we do that. Because it also needs basically to it with the like yep, that is the truth. Good thing I've been studying. Okay, if I do, yeah, I can just do this actually. Output, and it's expected. Now that's getting smart. Okay. Error equals error node error. That's just an per node. The error for each node. And now we need no, it doesn't matter. Actually, we need a node. No. We need errors. Layer error Wow. Put error. Errors, actually. Errors. Wait, no. Errors. Let's do. Errors are just empty. Great. And then we can just do errors with append the node error. This is very nice. And then we use return, I think. With layer errors. Actually, I'm gonna rename that slightly. Return errors. So we can get all the errors. Okay. Git error. Well, it's actually a bit more than I thought. How many modifications did I make? Did I? Mean square error. Propagation. MSC. BP. MSC. MSC. Railing. Back. Well, actually, I did output layer error. Methods. Oh yeah, it's not even fun. It's not a function. Function. It's a method. Because reasons. Nothing's named fun anyways. Unless it is. In which case I'm not renaming. Okay, cool. That pushes it to GitHub. Nice. Okay, now we get the output layer errors. It doesn't. I don't use this for everything. Wait a minute. No, I don't actually. I forgot. The other guys use the different ones. Do a different method. Okay. I should build something with this. I should be building. So here we have the what? Activated. Hidden layer activations. Weighted sum of the layer. Who knows what that means anymore? The weighted sum of the layer. Okay, that makes sense. Okay. The output. Oh wait, that's the output layer? Ah, sweet. So output layer with the rail activated. Oh yeah, we activate the output layers values. Rail activated. What do you mean? Rail output layer? No. Oh, because I was using single value. Right. Okay, we're gonna go to Next.js. Actually haven't. I'm not sure, maybe I've heard of it, but I haven't ever used it. No, actually, I don't think I've ever heard of it. I've heard of Node.js, but I've never used that either. Neurons, okay, multiple neurons, some layer, feed forward, I need the rail. The original. Activations, okay, fine. We might... Okay, fine. Activatables. Activate publics. Activatables. Maybe a word, maybe not a word. Relations will be now this. If len, exactly len. Len of activatables. Number 1. Then we can just actually use this. It might just be curious. Might be 0. 0 element. Also, I don't know why it's 0.0. It's 0. else. In other cases, we just do a bunch of work again, a bunch of following again. And this is becoming a lot of work for the activation. Activatable in activatables. Also, you're. Ooh. Come here. There you go. Okay. It's actually the max. We are using the max. Max of activatable. And activations. Append. Well, they fabulous. Return activations. Next is on framework reactor. Nee, dus ik heb dus maar reacting pijl aan de hele element doe ik alweer. Oh, ze hebben React. I've never used React. There was technically a course on it, but I did something else. I did a different course, web dev course, so I didn't need to do anything with React. Return the activations in other case, yes. Activatables, activations, okay. What if my output layer is bigger now? Hidden layer activations. Wait, what? Where's some layer? Wait a minute. But the way this, oh god, did I wait a some layer deal with that? Where is some layer output? Not really? What the? Who was ever using Raylo? Nobody was. Ah. Oh wait, if someone wouldn't use it because it doesn't make sense for it to use it. Yeah. Nah. Feed forward. Okay. Assuming we start from 0. I'll feed everything to Raylo. I mean, we could have just done that. We could have just left this be. Outputs, several Raylo output. Okay, fine. I already made it. I might as well. Actually, double action. Double action. Hidden layer outputs will now be Raylo out. Hidden layer outputs. Layer outputs. Because it doesn't matter anymore. We don't need the other guys doing the job at this point. I didn't break anything, did I? Maybe I did, maybe I didn't. Who knows? Who knows? Object has no line, you have no line. Oh, I don't know. I know what's going on. Is that other Raylo guy? No, you don't. You don't. But output layer, wait a minute. Why didn't it work? Wait, many waits. Okay, cool. Why should I care? Activation equals no ops. Activation equals neuron ops rail. Oh wait, no. That who's calling that? At line 123. What? Oh, might be the other guy. That might be the problem. Huh? Now, why doesn't about float? Why are you? Ah, right. Okay, that's smart. That's smart. That's a good point. Very good point. Where is some? Could they just? No, I have no idea. Yeah, actually, that's gonna really mess with my brain. Mitä tutkintoa opiskeltaan, because it's the software engineering, like ohjelmistotekniikka. It focuses mostly on the whole how to make software, how to program, but it's kind of starting to feel like it's mostly web dev. Weirdly enough. But at least this semester, this currently going on semester, is the final semester of all this basic stuff. Then it's something else. Okay, if type variables equals int. Wait, how do I check this? How do we check? How do we check? If is okay, wait a minute. Foolish me. I can actually check. I should have a list somewhere. There's the. Wow. How do you? Wait, there it goes. Okay, let's see. There was. How much was that actually? Okay, I don't think there was that much. I think I'm over exaggerating. Because I took a huge course on it. I don't think that's part of it. Maybe. I didn't take that course. That wasn't either, really? Okay. Okay, I might have over-exaggerated. There's like... There might be more, but I don't think these other courses talk about it. There is databases, which is part of the web dev stuff, and then there's at least two courses on web dev, so not a whole lot. So not a whole lot, like 3 courses on web dev. Well, arguably 4. Maybe 4, maybe 5 in total it's gonna be. So not a whole lot, but a few. Too much for me. Yeah, not a whole lot. Yeah, okay, I may have over-exaggerated. It's like 4. Actually, mitä so there was the databases, there's also... There's how do you explain web? There's from what I remember, one of the one course I didn't take it because I've already done it is or the two courses. One of them focused on using React and building websites, as far as I understand, to basic web development, development. This other one, I think it expands on it. I think it just expands on it. I'm not taking it, so I don't know the specifics. But it seems to be just an expansion on it. So 2 courses on it. And then there's technically a project, a bigger project, which focuses mostly on teamwork, or the Scrum, DevOps, and so on, agile methods. But the project is web dev, making some kind of website. So using APIs and stuff. If I remember correctly, I did not need that. I just needed to check if list or list, if it's list or int/float. Itu tiedosta? Yeah, no problem. If I'm not wrong, there's probably a degree in web development specifically somewhere. There's different degrees for the computer science sector, or I guess technically in Finland it's information technology. Is instance, okay, wait, is instance? Okay, well, that works for me. If not, no wait, if instance the is int and float. If the float or int, well, then that wouldn't actually make sense. This doesn't make sense. This has become irrelevant. Single output. If single activator, single single neuron to activate. Just now realized I probably wrote something about nodes here, which is kind of wrong, but it's fine. Activations happen max activatable. It's basically the same stuff, but slightly modified. Well, actually, I don't think we would ever. No, we could. Our weekend. Activation 0. Okay, activation. This presumes I give it only one activation, which yeah, I would give it one activation. Okay, cool. So now, how about it? You gonna work? Okay, never mind. Bye. With an activatable 0. What the? Oh, right. There's no index anymore. At least for you. This object has no attribute dim. You have no dim. Oh yeah, good point. NumPy.array. It needs to be an array. Why does it keep writing multiple R's? Another letters. Probably because the computer is dying. I needed. Where was? I'm pretty sure I made an empty array somewhere. Oh, there it is. Sweet. Wait, but then how did I give it the values? Interesting. NumPy that append. Huh. Right. Now I remember. Okay, NumPy. This is gonna modify itself. NumPy that append. Okay, cool. Shh. Next one. 2 activations. Teetkö tätä neural networkia vaan omaksi hubiksi vai liittyykö tämä sun opintoihin? This is for my own fun, but it's also, it's not specifically for this degree. This is just more future degree. So for master's degree, I'm preparing. I'm learning all I can, so I'm ready. I need to learn all of this to become, you know, a researcher. Okay, how about this? This has... Actually, I should go and fix myself. I have no idea why that's empty. And that's probably not a good idea. Good thing. Oh wait, whoops. It's the exact opposite way. Boing. Activations. Okay. This way. How about this way? Okay, I didn't fix anything. I'm not sure if that's right or wrong. Did anybody use... Somebody used list and they weren't supposed to. Right, you. Man. Why did you do that? There you go. There you are. No, Hadamar no longer. That's probably not the smartest name scheme. Yeah, moron. I don't know rest. No. Let's just take the rest. And then you also rest. Okay, cool. Armor product technically not used yet. That array will get there when we get there. NumPy that append. Errors appends the noodle. And then you just return that. Cool. Okay, now I'm not sure if it's supposed to be empty. Who's printing and what? Okay, print activation 0. I don't know if that's what I want. Wait a sum. I can't tell if what it is. Print weighted sum. Is it this? And this should be a single value. Negative 3.0. Okay, that makes 3. That makes that makes sense. Maybe. If it's this, if it does. XVB, man. So we have yeah, what if I make this positive? I mean, I didn't know if it should be. Oh, wait a minute. Do I have an answer if I go high enough? Activation wave. What's the last arrow? I think it's a bit late for that. What's that doing? What's that doing? Okay. It's doing its own stuff. Wait a minute. How far behind is this? Where in the universe is this one? Oh, wait, there was a... Okay, no, there's more than enough space here. 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0. When does hello come up first time? That's when we know things are still working. Wait, that was it. Yeah, it was already doing it. It was already zeroing out. Perfect. We don't need you to do anything else other than that. You do your activations. You get your outputs. I think those are the same. Yes, they do seem similar. Activated, okay. Output layer, hidden layer, output layer. Hidden layer activations, and then output layer. Rail activated. Where's my output? Oh yeah, my output layer is currently of size 1. Right you are. Pitäisi varmaan itsekin aloittaa joku webdev-projektin teko tässä. Yeah, that's a good idea. That's a good idea. You get a head start. What am I missing? Am I missing something? Alright, I wanted to make... wait, is the output layer... it could be. It should have multiple. Hidden layer activations. Right, hidden layer activations. Those do their own stuff. Wait a minute. It is... comes back with... empty. Oh. Otan aina uusia projekteja, kun ei millään jaksa tehdä aiempi loppuun. Well, that's a habit. Might have to fix that a bit. I do understand not wanting to finish certain projects. It's a lot more fun to do the initial stuff, but then by the end of it, it turns into mostly just testing. So many tests. Okay. Feed forward. Why is it feed forward in its ass? Okay, the output should give us something. Okay, let me do run. What the hell is 9 doing? Okay. Ooh. Actually, you do hello, and I find out. I found out what hidden layer is hiding. Delay activations, yep. Thank you, Python. Ooh, outputs. Actually, why am I doing activations? No, it's outputs. Outputs. Okay, cool. So what happened? Makes sense. So the first one had something, the next one had nothing. Nytkin varmaan jos aloittaisin tekemään jotain uutta projektia, niin en jaksaisi tehdä sitä joku pari viikkoa, ja sitten taas motivaatio loppu. RIP. Yeah. That can happen. Might need to Might need to fix it. Might need to fix it. But maybe you can come back to it eventually. You know, when you have motivation. If you have. Daniel, introduction article on VCU TV Philadelphia on October 16, 1993. Ownership section. Daniel, we're not doing this. I don't know what you want me to find in there, but you have fun with it. Ik wil je kanaal motivator gaan tietoa omia projekten. My motivation stops mostly once I have to actually write reports or documentation and make tests. Like web dev, in the web dev course, it was really mostly tiring to write the tests for each thing. It kind of gets boring. So that's when my motivation dips. But otherwise, not that much. What is BZAW in October according to Google results? Hey, no, Daniel, you can find it. You can find that out yourself. But for most part, my motivation can't stop because I keep doing different things. I mean, project, but that doesn't mean that project-wise it does drop sometimes. Good point, me. Or does it? I've done a long enough project for that to happen. I mean, I guess I do take days off. Interesting. I'm learning more about myself. Railway hidden layout. Was the one off for VGW paragraph from October? Daniel, I have no idea what is up with this WCAU TV stuff. Okay, why is it doing that? Wait a minute. Whoops. Whoopsie. You sure? Okay, who has whoops? Whoops. There's a couple of whoops. But the rest aren't. No, mutta kai mä tästä nyt lähden taas aloittaa uutta projektia. Well, have fun with it. Good luck with it. Good luck finishing it. Why did this explode in my... Ah, that would explain. Wait, no, it wouldn't. Oli kiva puhua, kiitos streamista. Yeah, anytime. Well, when I'm live. Have a good night. I think that's it. Yep, it is. Nighttime. That is very curious. What's happening here? Relatable. Oh, is it too thick? How thick is this guy? Hello. Okay, you have these values. Now, NumPy, why aren't you taking them? Oh, good point. Okay, I see the exact error of my ways. I see the errors of my ways. Error of my ways. Activations. Activatable. Right, that fixes it. Yeah, that's why you need the equals. Haha. Haha. What is Comcast? Bro, I think it was some American TV broadcasting place. TV broadcasting, or some kind of broadcasting firm? Company? Something like that. Okay, okay, we don't need this anymore. Now that we fixed it. You know, surely we fixed it. Oh, where's the errors? What happened? Why is it? Why did it get darker? I have no idea. Oh, I would explain it. Whoopsie. Oh. Wham. Oh, hell yeah. There we go. Final version. 1 -1 0. My bro, my dude. What the? What happened? What happened in between my activations? What happened? What happened? There's supposed to be different values altogether. I believe it. Oh. You have lied to be in a pipe and what a more dress, of course, in a pipe end. Is it maybe I made a mistake in the ears? Nope. That's feed forward. While hidden layer input sequence hidden layers minus 1. We take waste, we take subweighted, if not multi output. Wait a minute, what the? What was the owner of the ZTV? As follows. What was the ownership name for October or the Philadelphia answers? Dude, bro, I don't know. And I don't have the answers. You must consult ChatGPT or Google yourself. I'm also seeing the exact problem I was facing. Someone deleted it. What did I do? Uh-oh. 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 Oopsie. Hidden outputs equals self.railing hidden layer outputs. Oh yes, this'll work. Well, I got into Google ownership name for VWA TV-DV Philadelphia on October 16, 1993. No idea. Google. Tell me. Google is not answering. Good. I don't have a Google. I don't have Google activations. Voice activations. Oh yeah, that's a different output system. Alright. Alright, that works as it's supposed to. As it intended to. Wait a minute, then why am I doing this? Am I sure I didn't mess up? No, I didn't. It works. So feed forward is feeding the forward in the network. Wow, 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 wow. Okay, the stuff is going forward right now. So now we need backpropagation. Looks up ownership name for DDC on October 16, 1993 Google. Nah, bro. Okay, I'll entertain you once. I entertain this idea once. If Google doesn't have an immediate answer, We don't Philadelphia. Yeah. Ownership. Owner. October 16th, 1993. It is not an answer. We give it up. We give up. It does not. Oh, what was the owner? Okay, I guess it's some kind of answer. Sleepier's TV, that's the closest you're gonna get. The feed forward is doing that. Doing its job. I kinda just need this. It's gonna be modified. Oh boy. Oh boy. Ooh. Can I make a lambda key? Can I make a lambda for zero if value 1 or less than 0 and 1 otherwise. Otherwise, that I could use for different use to check use on other variables. The lambda variable. I don't know if that's right. Oh, Daniel. I don't know what this magical Philadelphia stuff is, but it sure is something. I need to focus on this code right now. Interesting. The variables and it's what do you do? Hell yeah, I can. Okay. The what this tables. Then we need a that's good enough. 0 or 1. Result equals no x. What is it? Activation. Activation 0 if activation is less than or equal to 0, else 1. Activator max no this is activator activatable ownership of one. Oh, Google's and all that. No. Why did I put it there? Whose ownership? I think I did already. The answer has not changed. There's something CBS. To ban over this. Yeah. If an instance is activatable, then return activator activate bubbles. Yoink, yoink. Else. Man, that's so much code. Good, I won't have to do this again. This is Raven 0 or 1. Ooh. Zero or 1. Is it like this? Can't remember. Damn it. Still. I think it's a single arrow. 0 or 1. No, I'm getting hungry. I have do nuts. Many donuts. No. Wow. I need sugar. I've burned through sugar fast. Oh, mom. Where's lambda isn't just activated. Daniel, we've already wait F W T X F. No. I gotta focus on this. But there's nothing weird here. Very cool. Updated Relus to use to handle single handle vectors get push. Get push it in, push it. Also, I may have fixed errors, but unimportant. Less important. I need to fix this. No, I'm done here actually. I've fixed that, I made that work. I have to be next step then. I have some next step that I don't know what it is. It is something though. It's what do we have is the question. We have the feed forward. It works as expected. Output layer errors. gets the gradient mean square errors for them. It gives us all of them. That's not actually the errors. That is not yet the errors. That's the self mean square. Node MSC error. MSC error. MSC BP error. So errors shouldn't even be doing this yet. Oh, for fuck's sake, stop. You stop. You stop that. So we have that. Ownership name WTXFTV. Oh my god, Barracraft? I know. Okay, I'm gonna just. If I can't find it on Google, I won't find it on. Let's see what it is. Okay, well, technically I was supposed to look at own. Oh, it's Fox, I guess. Where's the station? Maybe they own. Owner Fox Television, no way. WIB TV, VTA, FTV, yep. Many TVs own them. Yeah, cool enough. Right now I must look here. No. But then I need Hotmart product. Actually, no, I need the Railu versions for my outputs. Huh. Oh yeah, because of reasons. Well, actually, now that I think about it, yeah, okay, I got it, I got an idea. Okay, not an error, by the way, here's an MSA BP. Because the mean square error is already included in that. So what I need now, most importantly, is the activation BP equals self.railing backpropagation of the, is it outputs? I think it's output. And then errors will, they can actually, it's times. How to mark? It's times. So it's element wise, because it's element wise, we'll just do this. What is the name to a common central? Didn't we already do that last time? Relation BP no do, okay, well, fair enough. MRC BP? What's the matter? Node. It should be node. Neuron. MRC BP. Stuff with the asses. Okay. That should still work without any errors because I haven't done any yet. Errors? Okay. Cool. Layer activations. Feed forward has done something. Wait, why do we even use the hidden layer activations? We don't even need them technically. Okay, I want to do something which is Ooh. As for each neuron weight. Where does some feed forward? Wait a minute, does that make sense? Ownership is central. No. Do something. Anyways, a very curious thing. What are the weights there? That's the first, second, third, fourth, fifth neuron. There's the weights for all 5 hidden layers. Hidden layer neurons. I mean, we don't have to do our own stuff, technically. Let's assume. Let's make yeah, what was the comedy center? What was it? You know what the comedy center was? Try something. TV station. Another TV station. Okay. Output fuck me. Put output L, big L. Hell yeah. That's the good stuff. Maybe the feed forwarded. Once you finish that, I'm gonna use the layer last output L errors neuron ops dot. I mean, that would be the layer. I'm gonna make a separate backpropagation function, I guess. But for now, I just wanna see if this works in the way that I want it to. Layer output layer errors. Okay. Command Central as of October. Private TV station still. What are the options? Output layer, okay. Output now. Expected layer. Right, I don't have that. It's 3, 4, 5. Expected layer. Let's say there's E equals X equal expected equals non-plotted array. Okay, we wanna have the outputs. We have. Doesn't really matter. Let's just, for simplicity's sake, have 1 0 1 0 1. Okay, good enough for me. What was the owners for Commerce Central? Who knows? Some dudes. 3, 4, 5. 5. 3, 4, 5. Okay, for simplicity's sake, let's keep it equal. I'm gonna have to test it out with not that dimension. Put our errors. And it broke. When did it break? And what end? Oh, yeah, I know. I kind of forgot, I think. And then output layer equals 1. 145 or something. 71. Mean squared back propagation. Ah, that's a good point. Instance is this. If it's if the instance is activatables, no. Output a layer interflow. Then do just output the minus the input, yeah. I think it's the exact same there. Mean squared error. Okay, it's the same idea. The error. Okay, cool. But that's not so important. What I'm most interested by is the output layer. What is it? No, wait. It returns that if it is just that mean square error. Mean square error. Yeah, that makes sense. Attribute neural network operation object has no attribute value back at what point? 104. Oh, back propagation. Back prop. Then it should work. So it does. What did I do? Oh wait, I got the errors for output layer. I'm not sure if this is correct. Those are correct. Wait, they aren't correct. Okay. But why aren't they correct? Rail backpropagation? What in the fuck? Activation, activatable, activator. What the heck mean? What is the mean square error doing? What is it doing? Wait, it cannot be, or it can. Or rather, more accurately, it can be. It's the rail product of that, so whatever that is. So let's just make sure this is actually doing what we kind of expect it to do, even remotely. I know what I'm doing, so I should be able to understand what the output is. Right, I'm half understanding what I'm doing. Thank you. Okay, we got those. So what do we get out? Okay, fuck me. Okay, so we get out 5 from the mean square error backpropagation. I don't know if that's right, wrong, nothing. So we get 5, then with 1 from that, we get a 0. 0, then we get 0, then we get 9. 1. So it's those two. Wait. Oh yeah, the other was. The end result is a. The errors are 0, or the errors are 0, 0, 0, or 9, 5, 9, or something higher. in backpropagation, can the values what's the owners for comedy central was owned by only people by people I'm gonna say people makes sense. Or maybe it was lizard people. Then the values for MS for course the message or the message derivative for the error can the for error be what value what values can the errors be? Okay, I think I may have just created a huge issue in my ass with ChatGPT right now. Okay. What is it? GPT, tell me. You cannot leave me hanging. You can't leave a bro hanging. Oh. In the context of backpropagation in neural networks, there is typically reverted the gradient of the loss function with respect to the output of each node. Yep, I know that. Overall error. We don't need overall. No. Yeah, number 3. I think it makes sense. It should make sense because we already doing it 2 times, so it would already be greater than greater than 1. So whatever values we get out of mean square error should be higher than that. But there's a good point that does that make sense? No, does it? I don't know if it does. No, it does. It's only the activation function that differs between the values. Yeah, this is all making sense so far. Okay. It took practically forever, but we have made the output layer errors. Number the error. Good enough. Okay. Then, what would be next? How difficult is it? Okay. Okay, how long have I been at this? is a big question. I think it's at least a couple hours. 3 hours, huh? A bit less than I was expecting. Okay. Fine. Backpropagation. Yeah, what does it take into itself? It takes in the cell, but then it takes in the... Does it take in the inputs, the weights? What does it do exactly? I mean, backpropagation starts from double layer errors. Okay, we need the output layer, the expected layer. I can make a separate one. Nah, I don't want to make a separate, any separate for this. Just keep this. It's not the prettiest, but whatever. Put layer errors. And what in the universe? Errors. Oh yeah, it's supposed to be self. Self dot output layer errors. We can pretty it up one day. Expected. Okay, it's the out layer. I don't know what that's the first option to give me. Google Computer Central still on about that. Me? No. No. Expected layer. Okay, that is... Why did you do this? Why have you done this? Why have thou done this? Done it this? Okay. Output layer equals error equals and then next layer error. Wait, next layer error. It's for all. We do them for all of them. We would have to know how much. We'd have to know so much data. So much information. We'd have to know the problem is we have to know the we have to basically know everything. Because we have to know the weights as well, all the layer weights. Output layer errors, we could get those, but I don't wanna. No, we could get layer errors and... You have to know that... We'd have to know the amount. Layers. Number of layers. We'd have to know the number of layers. Number of layers. We'd have to get a full list of the weights. So we need to get the full list of the weights. That's what I need. I need a full list of the weights. Can feed forward, give it to me. All weights to me. Oh yeah, feed forward, there is something. We weights. Okay, we need to actually modify the feed forward because it's currently because it can't keep up with it does. What? Ah, shit! Interrupt me. Oh, don't. Okay, put that to the side. Okay, I have an idea. So let me think. We need to feed forward, but feed forward doesn't. Not the first one. It doesn't need anything. Wait, maybe it shouldn't be. Wait, no. Maybe you should just use the weights already predetermined. Maybe you require. Sample is simple or in PyTorch. Okay. Maybe. I have an idea. I want to copy what PyTorch does, I guess. Do I need to define the weights myself first, or are we expecting the feed forward to do that? Triple C, hey, could you do your job? Ooh, I didn't have coffee though. No, I don't. Neural network, yeah, theirs is 100 times better probably. Getting size out, but size, simple, super. Yeah, what is the F? Wait, what? Me. FC. What is FC? Neural network linear? Raylo. Okay, Raylo makes sense. Hidden size output self-sigmoid. Okay, well, I mean, you can use the sigmoid as well. Oh no, this is the forward. What is FC? It's not feed forward. What is FC? Self.FC. What self.FC? FC 1, 2. What is that self.FC 1 and 2? I'm gonna confuse on that part. Simple neural network. Damn it. Taking off. It's sweet ass time. This is fully connected? Ah. And a linear cartridge. First food. The hidden layer. The input size and hidden size. Neurons the hidden layer. Ah. It's a secondary. Okay. So the hidden layers, basically connectors, are creators. Input size with hidden layer. It gives it that. Then the rail gives us the rail, and then that forward takes the fully connected. Then the rail, and then the fully connected again. Then the activation. Wait, the activation is only after? Why would you do the activation afterwards? Would you have to do it after first? Before? What? This is working in the bizarre ways. Mysterious ways, you are. But input size. Okay, input height, hidden size. Okay, output size. 1. Okay, criterion and the BCE loss. With those optimizers random, I don't exactly know what some of those are, but model or input data. Outputs equals model input data. Oh, where's the model coming in? Alright, there it is. Criterion, where'd you get that from? Criterion? Oh, right. Radius? Forward pass, okay. Optimize step. In optimization. Step, what the f... I guess I can't understand it, maybe. Optimize that step. Optimize that zero gradient. The gradient loss that backward. It's working on a level, all different level than mine. In the hidden layer? That makes sense. Matrices and the layer contained. Wait a minute. Input data random 100 input size. Random 100 to the input size. What the fuck? Or 100 between 1 and 100, I suppose, and input size 5. So 5 possibilities. Then I guess the model, you feed that input data to it. Forward, where's the forward happening? Forward never gets called. Unless it does. Oh no, it doesn't. Outputs. That doesn't make sense. Where is the... No, I don't see the forward ever being used. Maybe. Sync. Example. Okay, I'm gonna see this like this. Backpropagation. Oh yes. I'm so close. Neural networks, convolution, supersampling. Well, I didn't need that. As a convolution neural network. Not what I was expecting. The fully connected first one, okay. Input size, so how big it is, and output size. Wait, is it output size? No, hidden size. How much this hidden layer has, okay. I need 20 things. Wow. Wow. 84, 10. Okay, whatever. If I'm forward, it's too complicated. That's I did put in simple. You put in a convolutional neural network out of everything. I just wanted a very basic one. I didn't need a huge thing. Define the model. Yeah, that was my whole point. 8 variables, but yeah, it was in 12 layers. Oh wait, that's followed by a rail. Okay. Wait, what the crap was that way doing? Oh wait, I'm a dumbass. Followed by rail linear. Followed by sigmoid, huh? Forward. What is the purpose of forward? I don't think you ever used forward. Did you ever use the forward function? I don't think you ever used the forward function. What was the... I don't know. Where did you... When was the forward function called? Function called in the code? In the code. When was it called? I don't think it was called at all. I don't think you called it a single time. Are you sure you called it? I think you just made something nice. I think you lied to me. I think you've lied to me. But from what I can understand, the weights are done internally. As an input data. Passing input data as an argument. I don't know if that is true. Super. Oh, maybe it's because it's neural network, that module. Yeah. Yeah, that makes more sense. So that's this time PyTorch handle the weights biases internally. Does it handle them or? But it's interesting, now I can actually read the code. Because I've seen PyTorch code before, but I was about as lost as ever. Now I have an understanding, which means I'm closer to advancing. So I could define the weights, or I could not. Define them. Okay. It handles the weights. Okay, so we also need to handle the weights. When you do the feed forward, yes. Number of hidden layers is greater than 0. Okay, we feed forward. And the weights here are defined for the first pass, but they're not fine for the second one. So we have a bit of a problem. We need weights. We need weights. That's all. Hidden layers. Okay. 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 Oh, hidden layers. We'll do that. And then we do. We need weights. We need to keep track of the weights. By the time you're done here, you need to give me the weights. But you can no longer use the weights. I think I have a plan. Wait a minute, by the way, did I... Okay, YouTube is still playing. Okay, I don't have a plan. I do have a plan. Maybe I do, maybe don't. The supporters handle ways and buzzers until it does. Okay. I mean, they have more advanced stuff. I could make similar, but I don't really want to. So I could just... The simple way would be to just make another parameter. Set that the weights and to be none. No, set that to be weights and even none, then set that to none, even on, then it didn't do anything basically. It didn't do anything with it basically. Otherwise, move forward. Or if it's none, then use random weights. Or if you already know the weights, then use the new weights. The question is, can I? Okay, screw it, we're doing that. Weights. Because none. Even. Whoa. I died. Where's signal? Oh, I think I hit the goddamn cord. No mind. Weights. None. None. If weights equals none, then we just wanna. Damn, that's the problem. We need random weights for all of that. Outputs. When I use the weights, I'll have to make a. I'll have to make something for that. No. Okay. random. But I don't need. One hand, I'd need an equivalently sized one. Equivalently sized to the inputs. And also have to make that. Random, and I have to make that. I have to make that equivalent. Equivalent size. But then we'd have to feed the inputs in ways at different times. I have to have a index for the weight. Wah, wah, Da-da-da-dum. Da-da-dum. Weight size is the same, okay, very weird. Weight size. Size from one. It's inputs by where? Does this still work, by the way? Okay. Expected 2. 1, 2. True. But that shouldn't be affecting it. Are you really saying that it's gonna get in the way? Oh wait, that's a different thing. Or maybe it's not. Inputs and then weights. Haha. Of course. If I have the weights, then can you pack those? Ah, you can. Okay. Nice. But now we need a bias for each layer as well. Okay. Ah. Wait, why am I doing that in the first place? It doesn't make sense. Bring weights. Bring the weights. Why am I getting so many prints? Who the hell is printing? I get it. We understand now. We understand you are printing. How do you print? Can't print while I'm doing nothing. I go leave this. Oh, but I'm starting to understand something. that would make weights for each neuron. Okay. So we have a 4, 5, 5 by 5. Yeah, I get it. I get the meaning. It does make sense. Random uniform. Uniform. Okay, we're gonna need a depth and then size, length. Whoops. Length of inputs, right? Bases. Ah, the a bias equals the biases. Biases. Right, well, I need to even get those out of here. Biases, index attributes. I mean, in what the fuck? I keep doing that. I keep not reading where I am. That's probably a bad sign. Sign of my code. This is in the plus equals 1. If I'm not wrong. Wait, no, shit. It's no, it's doing for each way. It's doing for all the ways at once. Use the by. Wait, no, it's for each layer, right? 1 layer, 2 layers, 3 layers, right? Was never closed. You never closed. Random inputs. Now this should do something. No idea what the hell I did. It seems to be fine, I guess. Print basis. Okay, there's a very low biases. Yeah. So we need those biases, then we get the random weights. Okay, we'll need biases equal to none as well. These equal none. We'll leave it as is. Weights and then biases. And we need here we need the the weights. Okay, biases. You get the biases, and this is then we compute the errors. You compute the errors, and you can feed those forward. No, the rest of backpropagation can, I guess, do it. Can it? Does it even need it anymore? No, it needs the expected layer. It doesn't need the expected layer, and then it needs the weights and the biases. Weights and the biases. And then I'm gonna fix my Jesus Christ, why does the cord keep getting tangled? So, that's very odd. No, but never mind. I can back up. Ah, yeah, well, I was just doing its own thing. Come here. Come here. Wakey wakey. Oh. I guess it really doesn't want to remember its screen. The working area, I mean. Why can't it remember it? Is the question. That's really weird. Anyways. Okay, thanks. Okay, wee. Okay, I got it, I got it. Okay, we got the up there, errors. Weights and biases. Okay, well, kind of want to do expected values. Yeah, we'll do print. Let's do backpropagation. No wait, this would be neuron. Let's go ops. Backpropagation. I'm curious. Output now. Weights. Biases. Wait, what? E. Expected values. E. Now let's undo that and do that. And now, when we do backpropagation, do that first. Okay, return errors. Let me just make sure it's still doing what's expected to. Oh wait, weights and biases. Wait, I know I did give it the weights and biases. Yeah, those are pretty big numbers. I don't know what's going on there, but it's fine. Is it possible? Biases are very... Is it possible that the biases are just randomly getting high values? Ooh, no, feed forward was done here. Was done. Automod, MSC. Okay, we don't need to look at this right now. We need the feed forward. I need to print basis. I have a feeling I know what the biases do. Wait, there's a high AS value for that. Why though? There's a very high output. The weights should not be able to do that. So why is it 1, 2, 3, 4, 5? Why is it that some of them are 50? I don't think that's that should be possible. Unless it is possible. 7, 8, 9. Okay, the weights. Now we have random weights here, but feed forward. I mean, this is the error, right? Okay, no, the outputs are, I think they're fine. It depends on what I'm printing right after. I'm gonna feed forward. No, that's the biases, okay? It doesn't seem to be either the biases or the... weights? It doesn't seem to be either one of these. Yeah, it doesn't make sense. I don't know how it could jump out. Let's just run it a few more times. I want to see when it skyrockets again, because that was clearly doing its own thing. No, that's still within expectations. I want to see something that explodes. That is much higher. The weights and biases are completely fine, as far as I'm concerned. Okay, that's not good. Is it possible it happens during the sum? Wait, a sum? Wait a minute. Impossible, this is the very weights that I'm feeding it. Oh yeah! Wouldn't the weights layer be huge? Wait. Here's the biases. These are the weights. The first, the second, the third, and the fourth. Doesn't make sense. Oh. Does that make sense? No, there's 1, 2, 3, 4, 5. 5 layers of it. Okay, I guessing that makes sense. But we shouldn't be giving all the weights to the layer. Right, I think that's where we are making some issues, causing some issues. Okay, this is the... No, I think this is index as well. It should not be skyrocketing to 50k. I mean 50. Which might be 2D matrix. Okay, thanks man. Why though? Why did I make that rule? It doesn't make sense. Where's some layer? Yeah, but that's just for weight in weights. This is supposed to be for weight in weights. Why would we have more dimensions for weights? But then, you know, that's different matrix with some. Yeah, I have no idea what I made. Must be a vector. Must be a vector. Yeah. I have no idea why I did that. The way I did it. Okay, thanks, buddy. It waits. Oh wait, there's some output. Ah. Yeah, I think I'm starting to understand. Okay, never mind. So, does it make sense? No, it doesn't, because we have weights. No, that doesn't make sense. Any sense? This makes sense. Okay, we have weights. We have a layer. They have weights. No, wait a minute. It doesn't make this doesn't make sense. I'm right on that. Right on money on that part. This makes sense. This original makes sense. I forgot that it's 5 weights per each. It's like 5 weights per each activate hidden layer neuron. Right, per neuron. But the 5 makes sense. Okay, that was my mistake. That was me being stupid. The feed forward, you make whatever that is. Oh, but it doesn't make new weights and bases. Ah, that's a problem. Because we feed it one basically shot of these that we have. We will have to do int, but we have to change the size. We have to change the size. We have to create a even more multi-dimensional array. Oh, phew. Okay. Numpy. How do I make an as one neuron, 2 neurons that has equivalent, that has fucking chord again. Anyways, it has equivalent, not equivalent, but has has a list. It has an array, an array with has layers worth of inner arrays which each inner array aims up array respect to the matrix to the, is it 5 by 5? I think it's 5 by 5. Yes, 1, 2, 3, 4, 5. It's 5 by 5. Wait, is it making sense? Yeah, it does make sense. It's the first neuron, the second neuron, the third neuron, the fourth neuron, the fifth neuron. With corresponding weights Yeah, I don't know if it understood. Okay. Okay. Weights can be like this. Okay. Well, I kind of wanted the numpy array of it. So I don't know about that. This is per neuron. Damn it. Okay, blank in range. Okay, no mind, I'm not even typing that. Blank in range. Number hidden layers. But I wanna make this into an numpy array, probably. Array. No. Okay, that might make sense. Okay, something happened. I don't know what, but it did happen. Print. This is gonna be huge, bro. I probably also shouldn't be making it that huge. Okay, it has all the arrays, all the weights. Otherwise, I could possibly have one. For each activation, each neuron's activation. That's an easy. No. The previous version of this whole system did work technically. This is improved, but it's just something. I don't still think this is going. Okay, how does it get to 10? Can it get that high? Why is it getting that high? I mean, I did put in some pretty hefty values. But I don't know if it should be. Can it get above its intended activation value? No. No, I think it should be flooring it, if I'm not wrong. Or should be making it like 0, 1, or in between. No, I can't. No, I wouldn't do that. Not every time. I think mine is just activating very highly. Very high activation again. I didn't. Oh, the errors, right. Oh, Okay. We are giving it the weights. We wait. The random weights biases, it goes through them, uses them to calculate the. It would be curious to see when it breaks. Is actually what I would be most interested by. Well, I mean, it might not be breaking at all. Let's be clear on that. But it might be. But it also might be. Okay. It's already 18, and then suddenly 35. I don't like that. Up and down. What is 18? If we question the feed forward function, the y is your. Oh yeah, we aren't even storing the outputs. The hidden layer outputs, I mean. They're not very good. Okay, it feeds them the. Well, that makes sense, I suppose. But where's indices and biases? Some layer. The sum of the layer. Okay, Drag by some inputs. Okay, weight 0. It does not affect the bias. Yeah, that's good. That's the bias after the fact. So here, the output plus equals the input weight, input times the weight. Does that make sense? Phew. Feed forward, feed forward, weighted sum. Maybe have a note about this. So we know where some. Okay. Yeah, it is the input times the weight, and then the bias added to that. So if you have an input of like 7, then 7 times, then I guess it does make sense that some of these values are gonna jump around. It makes sense for my values to be dead or somewhere. Number dot. Yeah, well, I know that I could do that with the dot product, but I don't wanna. I guess expecting values. But here's my question: why is the backpropagation getting even? Why are the error values so high? Play errors. Okay. Mean square backpropagation. I guess. Square that and then you No, you don't square it. Actually, 2 times. You do 2 times. Which we actually technically do. We actually technically do. Int float. Yeah, I think that's. Okay, I want to make sure we're actually calling this. Hello. Should we call it how many times? How many times should we be calling it? 5 times, I guess. 1, 2, 3, 4, 5. Okay. It does call it appropriately. -0. Wait, how do you even do that? Alright, it doesn't have that anymore. Does now won't have it anymore. Okay, that's whatever. I think it works technically, so we don't need to worry about it yet. Worst case scenario, we ask ChatGPT, and then I have a fun time. Did anyone ever use Hadamar product? I mean, there's no real reason to use it, I suppose. I'm gonna have to use it, kind of. There's not much point. I wanted to use it. I wanted to use it. I'm gonna use it anyways. I'm gonna use it anyways. God damn it, I made it. I will use it. Activatable analysis. I think it's just cost. Cost. Oh, cost. I guess a gradient. Mm. If, many ifs. Okay. Assume only one. Assume. Nope. If only one value. If only one value. If only one gradient value. What a mod results, okay. Now you'll be passed through the self.HADA-mod. I know I don't need to do this on it, and it's actually wasteful to do this computationally. I made it! I can't let it go. I made the function, I cannot let this go. More product. Wait, does it even return what I think it should? No, yeah, it does. Okay, cool. Cool. Oh, wow. You're more naked. Oh, that works. Errors. Update error. Up. Mean square. Do. Let's see. Do. Error. Derivative and then. Holy shit, my phone actually makes a noise. I didn't know it could. That's good. It is broken as ever. Okay, okay. So, whatever that does then. Pretty simple. Element. Up. Product. Output layers. Okay. Now, we do the output layers. Weights and biases. We now have all of the weights and biases. Previous ones. We just need to do the transpose of them or whatever. Okay, there's some text. No, for for what? What end did I update? Oh, backpropagation. I think that's most of what I did. Push. Whatever. That's fine. Backpropagation. We'd have a. How long are they? How long would they be? Think about this. Backpropagation. Okay. We didn't have to take the weights. I have an idea how to do that. Sort of the next one. Okay, cool. Yeah, okay, that makes sense. And how more with again. Then we'd have the biases. There's basically 3 functions to create, and it's already late, and I've been here for technically over 4 hours. Okay, 4.5 hours almost. Okay, I think I'll have to leave this here for now. I did not expect to be this much work. I kind of thought this would be done in much shorter period of time, but now that I'm actually making it, it is a lot more work than I would have thought. Fun, but fun. Okay, I'll come back to this sometime. Not sure quite when. Hopefully soon. Okay, sweet. I'm gonna come back to this later anyways. I need to eat something. Okay, bye bye. Eat. Bye bye. Oh, let's see if we get a copyright claim again. Hey, that was fun last time. Well, bye bye. This propagation will continue more. Oh, hey, big brain. Big brain.